Okay, so in this video, we're going to look at some properties of logs that are really, really important to know as you go into calculus. But rather than just give them to you and tell them to you, let's see them in action first, and then we'll talk about what they are. So let's say I want to do the log base 2 of 4 plus the log base 2 of 8 and equal that to the log base 2 of x. I want to find out what the sum of these two logs would equal. Well, we could always work with the left side. And remember, by this point now, if you've watched the other videos, the quick way to do a log, so you don't have to write it out every single time, is to, when you see the log base 2 of 4, what it's asking you is what power of 2 gives me 4. So having said that out loud, hopefully you can see that would just be 2. 2 squared is equal to 4. Similarly, log base 2 of 8 is saying what power of 2 gives me 8? That would equal 3. So the left side becomes 2 plus 3, which is 5. And if I now put this into exponential form, what this says is my base to the 5th, so 2 to the 5th equals x. 2 to the 5th happens to be 32 is my answer. So what this is saying, if I go back and think about my original problem, this says if I take the log base 2 of 4 plus the log base 2 of 8, it ends up equaling as a single log the log base 2 of 32. Now, what's interesting about that is 32 just happens to be the product of these two numbers, right? That is 4 times 8. Could be a coincidence, right? Maybe that's just something that happened on this problem, but let's see what happens on this next one. If what we saw happening here it would be true for this one, then what might, I'll put a little thought bubble here, the log base 3 of 3 plus the log base 3 of 9, if what's happening here happens on this problem, what are we expecting it to be? It might be 3 times 9, which is the same as the log base 3 of 27, right? We'll put question mark, right? Is it going to be that? Well, let's find out. We can always work out the left side. What power of 3 gives me 3? That's 1. What power of 3 gives me 9? That's 2. 1 plus 2 is 3. The exponential form for this is now 3 to the 3rd equals x. And 3 to the 3rd is exactly 27. So yes, that did work. Now I know I've really only shown this that works for 2 equations here, although I did do 2 equations that had different bases, right? So the base doesn't seem to matter. But it is true now, if you take the sum of 2 logs, as long as they have the same base, the log base b of m plus the log base b of n will be the log base b of m times n. This is the first of 3 big properties about logs that you want to be familiar with. So quick example of that, now that we know this property is true, if I had the log of 2 plus the log of 5, if I want to combine 2 logs to a single log, that would become the log of 2 times 5, which happens to be the log of 10. And remember, with log, there's an invisible base 10 there. And what is this asking? It's saying what power of 10 gives me 10? That would equal 1 in this case. All right, if you add 2 logs, it becomes a single log of the product of your 2 numbers. So what would make sense if I subtract 2 logs? I'm not going to give a proof for this one, but what would happen is it could be combined to a single log, but this time you would divide the 2 numbers. It's going to be the log base b of m over n. So for example, if I took the log base 2 of 28 minus the log base 2 of 7, according to this would equal the log base 2 of 28 over 7. which would equal the log base 2 of 4. What power of 2 gives me 4? That would be 2. So here's the second property. When you subtract two logs, it becomes a single log of the product of the quotient of those two numbers. Okay, the third property, we're going to sneak up on a little bit here. So if I had the log base 7 of 4 plus the log base 7 of 4, according to our first property, if I wanted to combine that to a single log, that would be the log base 7 of 4 times 4. But of course, 4 times 4 is 4 squared. Now, if you look at the left side, if I have a log base 7 of 4 plus another log base 7 of 4, these are like terms. So I could rewrite the left side as 2 times the log base 7 of 4. And so what this says, I'm not really solving for anything here, but 2 times the log base 7 of 4 is the same thing as just the log base 7 of 4 squared. In other words, this 2 in front of a log turns out to be the same thing as if that 2 just moves up here and becomes the exponent of this number. And you'll see it's not just 2. I left some room here. What if I added another log base 7 of 4 to the left side? What would change here? Well, now I would have 3 log base 7s of 4. And if I used my property, the first property we talked about, I would have another 4 here, and this would be the log base 7 of 4 cubed now. Okay, so it doesn't matter what this number is. This third property of log says if you've got a number multiplied by a log, p times the log base b of m is the same thing as the log base b of m raised to that power. That is our third property of logs. And so what we can do with these properties is solve a whole bunch of problems. Right now, this first one, we're just going to simplify this expression using these log properties. Because if I tried to do the log base 6 of 3, which is like asking what power of 6 gives me 3, that's not a nice number, right? It's not a nice clean number. Same thing with the log base 6 of 16. But it turns out this whole expression here simplifies to something really nice. Now there's two properties I'm going to use here. Yes, there is an addition, so I do want to add them. But what we first need to do is use this property we just talked about. This 2 can float up and become the exponent of 3. Same thing with the 1/2. So I can write this as the log base 6 of 3 squared. Let's put parentheses in there. Plus the log base 6 of 16 to the 1/2. Of course, 3 squared is 9. And 16 to the 1/2 is like the square root of 16, that's 4. Now, by property number 1, if I have the sum of two logs, I can combine that to a single log where I multiply the two numbers. So that would equal the log base 6 of 36. What power of 6 gives me 36? My answer is 2. Here's another situation where you can use log properties. If you grabbed a calculator and plugged in the log of 2, remember log means base 10, the log of 2 and the log of 3. Log of 2 is about 0.30 to 2 decimal places, and the log of 3 on a calculator is about 0.48. And if only knowing that, what you can do is if you understand these properties, you can evaluate some other logs without using a calculator. Okay, so you're going to use the properties. So here's how I would do it. For the log of 12, what I would want to notice is 12 is, first of all, 4 times 3. And 4 is 2 times 2 times 3. Right? So using our log property the other way, if I have a single log of a product of these numbers, I could break this up into the sum of those, the logs of those numbers. This would be the same as the log of 2 plus the log of 2 plus the log of 3. And then I have values for these. The log of 2 is about 0.3. And the log of 3 is about 0.48. This is 0.6. 0.6 plus 0.48, this is going to be about 1.08. And if you get a calculator and do the log of 12 and punch it in, you'll probably see it's pretty close to that. It might be off by a little bit because these are just approximations, but it's going to be close to that. All right, let's try the log of square root of 3 divided by 20. This is a log of a quotient. So the first step I would do is break this up as the subtraction of log of root 3. Now remember, root 3 is really 3 to the 1/2 minus the log of 20. Let's go ahead and leave 20 as it is. Now, we know that this exponent here from our third property can also float down in front, right? That could be in front of the log. So we're going to write this as 1/2 times the log of 3. Now, I want to somehow use these numbers to try to figure out what the log of 20 is. 20 is 4 times 5 or 2 times 10. Nowhere will you get a 3, and it seems like you wouldn't be able to do it because we don't have the log of 5. But if you think of 20 as 2 times 10, we can break that up as the sum of the log of 2 plus the log of 10. Why can I get away with that? Because remember, we are dealing with log, log, base 10. So what is the log base 10 of 10? This just equals 1, right? That's just 1. What power of 10 gives me 10 is 1. So then I have, if I plug in now, the log of 3 is about 0.48. Brackets are very important here because I'm subtracting, this got broken up into a sum, but I'm subtracting the whole thing. So it's going to be 0.30 plus, this is just 1. Half of 0.48 is 0.24 minus, this would be 1.30. If you do that on a calculator, I think you're going to end up with negative 1.06. Okay. Another thing we can do with these log properties is solve some equations that we couldn't have done before knowing these properties. So here we want to find the log base 3 of x plus 11 plus the log base 3 of x plus 5 equals 3, and we want to solve that for x. My first step here, normally what do I tell you? I tell you, if you get stuck on a log problem, put it in exponential form. The problem is here is we don't have a log problem, we have 2 log problems, right? So what we need to do is use our first property and change this to a single log. So this could be combined to the log base 3 of the product of these two, x plus 11, x plus 5. Now I can use my rule for logs, which is if I get stuck on a log problem, write it in exponential form. 3 to the third equals what's inside. 3 to the third equals this. And now it's just algebra. This is all nice and factored, but that would only be useful if this was equal to 0. So what I have to do, unfortunately, is, first of all, let's make that 27. I have to multiply this all out. X squared plus 5x plus 11x. And then that was 11 times 5. That's plus 55. Move this over. So that will make the 0 equals x squared plus 16x. If you subtract 27 from 55, you get 28. That then factors numbers that multiply to 28 that add to 16. I'm getting +2 and +14. So I get two answers, x equals -2 or x equals -14. Now here's the thing, you got to be really careful on these. One of these answers does not work. And the reason it does not work, if you take -14, now, of course, math teachers tell you to always check your answers, but that takes a lot of time. At least do this though, if you're solving a log equation. If you plugged in -14 back into either one of these, actually, but let's say you plugged it into here, if you plugged in -14 and added 5 to that, what that's going to give you is the log base 3 of -9. And remember, one of the things we talked about is you cannot take the log of a negative number. So this solution gets tossed out. Can't take the log of a negative number. The -2, if you test that, -2 plus 11 is positive, -2 plus 5 is positive. If that's the case, we're going to trust our math that that answer is okay. So our one and only answer here would be -2. Got two more problems here. Next one is log of x minus 2, parentheses x minus 2 equals the log of x minus 2. I like this problem because it reminds you parentheses are really important, huh? If I don't see parentheses here, I have to assume this -2 is separate from this x. In other words, it looks like this, right? That's a separate thing here. If we learn something from the last problem, what we learn is if you've got two logs, it's nice if you can just combine that, condense that down to a single log. One way I can do that is if I subtract log of x over to the other side. So I have log of x minus 2 minus log of x. That's going to leave me with -2 on the right side. Then I can express this as a single log of the quotient. That's the log of x minus 2 over x equals -2. And just like the last problem, once I get down to a single log, I'm going to put this in exponential form. 10 to the -2 equals my inside. 10 to the -2 equals x minus 2 over x. And now we're just going to solve for x. I think it's easier to write 10 to the -2 as 1 over 10 squared, which is 1 over 100. And if you've got a fraction equals a fraction, you can cross multiply. So that gives me x equals 100x. Got to distribute this 100 to both of them, minus 200. If I subtract that over, I have -99x equals -200. So x would be positive 200 over 99. We saw in the last problem that you have to worry about, one thing you have to check is make sure you're not taking the log of a negative number. So it's just worth a little quick check here that if you were to plug 200 over 99, which is a little bit bigger than 2, right? 200 over 100 is 2. So this is 2 point something, right? Probably 2.01-ish or something like that. So it's certainly positive there, and it's just barely positive here, isn't it? 2.01 minus 2 is positive. So then we're going to trust that we did our algebra right, and that answer is acceptable. One last problem. Another good problem emphasizing why parentheses are so important and being more specific about one of our log properties. Here, this means I'm taking the whole natural log, raising it to the 4th. Here, without any parentheses, the default would mean that it's only the x that's being raised to the 8th. Now, one of our properties involves bringing those exponents down. And so we have to be real clear about this. Here's our property. The one that allows us to bring the exponent down is when the power is only on the number inside here, not the whole thing. So that means it's only the 8 that can come down by one of our log properties. This has to stay. Now we still have two logs here, so we want to try to, I don't think we're going to be able to use any of our log properties to condense this down. But here's what I see. When I see this problem, here's what I see. I see something to the fourth equals 8 times that same something. In other words, you've probably done this before in your algebra career. If I let u equal ln of x, just to see how this looks algebraically, that's the form. It's u squared equals 8u. So let's try to solve this for u. Remember, don't make one of the classic algebra mistakes is to, at this point, is to divide both sides by u. If you do that, you're likely to lose an answer. So in general, you do not want to divide out variables. It's okay to divide out numbers, but try not to divide out variables. So instead of dividing by u, let's move 8u over and factor out a u. That's going to leave me with u cubed minus 8. So I either have, in terms of u, I either have u equals 0 or u cubed equals 8, which the cube root of 8 is just 2. The last step now, though, is I want answers for x, not for u. So if I replace now, this says ln of x equals 0, and this says ln of x equals 2. To get an answer for x, I can just put this in exponential form. My invisible base is e on both of these. So the exponential form here is e to the 0 equals x, which is 1. And here I have e squared equals x. Remember that e squared is a number. It's fine to leave it like that. You don't have to punch it into a calculator or anything. So you actually have two answers to this particular problem. All right, hopefully this will help you solve some log equations and knowing the log properties.